For this example, we'll be graphing a polynomial function. We have the function f of x is equal to x cubed minus 5x squared minus 4x plus 20. First, we want to use factoring to find all the zeros, and then we'll use the leading coefficient test and the zeros of f to graph the function. So, we'll start with our function. F of x equals x cubed minus 5x squared minus 4x plus 20. Since we have 4 terms in this polynomial function, let's try factoring by grouping. For the first 2 terms, we'll factor out an x squared, and we'll have left x minus 5. And then we'll factor out a negative 4 from the last 2 terms, and we'll have x minus 5. So this factors nicely as x minus 5 times the quantity x squared minus 4. And we can factor a little bit further because we have the difference of 2 perfect squares. So we get x minus 5 times the quantity x plus 2 times the quantity x minus 2. So if we set each of these individual factors equal to 0, these will give us our zeros of our polynomial function. So we set x minus 5 equal to 0, and we get x equals 5. If we set x plus 2 equal to 0, we get x equals negative 2. And if we set x minus 2 equal to 0, we get x equals positive 2. So let's go ahead and just plot those points before we go on. So we know that x equals 5 is a 0, so that's an x-intercept. X equals negative 2 is also a 0, and x equals positive 2 is a 0 as well. Now, that was part A. In part B, we want to use the leading coefficient test and the zeros of f to graph the function. So let's talk about the leading coefficient test. For the leading coefficient test, we simply look at our leading coefficient. In this case, it's x cubed. It's important to look not only at the exponent 3, but the leading coefficient 1. So, we want to talk about the end behavior of this function. Whenever we have a leading coefficient that is positive and the exponent is odd, that means our end behavior will go up to the right and down to the left. In other words, this curve rises to the right and it falls to the left. So, using this information along with our zeros, we can also do one other thing to get a little bit more accurate of a sketch. We can look at the y-intercept. The y-intercept will occur whenever we let x equal 0. If we let x equal 0 in our original function, we'll see that f of 0 gives us, we'll just have 0 here, minus 0 again, minus 0, plus 20. So we'll see that 20 is our y-intercept. Now let's go ahead and sketch this function. Here's our y-intercept at 20. We also know that this curve passes through negative 2 and goes down to the left. It comes over here, passes through positive 2, and then it comes up again and passes through positive 5. So we can see we've sketched a curve that has the correct x-intercepts and the y-intercept. It has the correct end behavior. So this is a sketch of our polynomial function.